Ever wonder how scientists know the formula of a compound? It's not magic, it's science. The secret lies in understanding the empirical and molecular formulas. These two distinct concepts play a vital role in chemistry, allowing us to explore the inner workings of compounds. Now let's start with the empirical formula. It represents the simplest ratio of atoms in a compound. Imagine it as the compound's most reduced form. It tells you the essential elements and their basic proportions. On the other hand, the molecular formula is a bit more detailed. It provides the actual number of atoms of each element present in a single molecule of the compound. Think of it as the compound's full identity, giving us a more in-depth look into its structure. So, the empirical and molecular formulas are like the DNA of a compound, revealing its elemental composition. Stay tuned as we delve deeper into the fascinating world of chemical formulas. Imagine you could convert water into wine. Well, that's not possible, but chemical reactions do allow us to transform substances. Welcome to the world of chemical reactions, where the ordinary becomes extraordinary. But what is a chemical reaction? Let's break it down. A chemical reaction is a process that leads to the transformation of one set of chemical substances to another. It's like a dance of atoms, where the atoms in the reactants rearrange themselves to form new substances, the products. Consider this example. When hydrogen gas combines with oxygen gas, it forms water. Here, hydrogen and oxygen are the reactants, and water is the product. The molecules of hydrogen and oxygen rearrange themselves in a way that allows them to form water. So, while we might not be able to turn water into wine, we can definitely make magic happen with atoms through chemical reactions. In essence, a chemical reaction is like a magical transformation, but with atoms. You know how baking requires precise measurements? So does chemistry, and we call it stoichiometry. Now, stoichiometry is not just any fancy word. It's a crucial concept that helps us calculate the amounts of reactants and products in chemical reactions. Just think about it. If you're cooking a meal, you need to know exactly how many potatoes you'll need, right? Same goes for chemistry. Stoichiometry is based on a fundamental principle in science, the law of conservation of mass. This law states that matter cannot be created nor destroyed. So in every chemical reaction, the total mass of the reactants always equals the total mass of the products. In essence, stoichiometry makes sure that we have the right quantities of ingredients for our chemical reactions. It's like the recipe that guides us in the kitchen of chemistry, ensuring that our chemical meals are cooked to perfection. So stoichiometry is like the recipe of chemistry, ensuring we have the right quantities of ingredients for our chemical reactions. Ever felt like you're solving a puzzle when doing chemistry calculations? You're not alone. Stoicometric calculations are the heart of chemistry, where we crack the code of quantities in a chemical reaction. Let's take a simple reaction as an example. Consider the combustion of hydrogen to form water. First and foremost, we balance the equation. It becomes 2 molecules of hydrogen react with 1 molecule of oxygen to yield 2 molecules of water. Now, how do we use this for calculations? Well, it's all about the coefficients. They tell us the mole ratio. In our case, 2 moles of hydrogen react with 1 mole of oxygen to form 2 moles of water. So if you know the quantity of one reactant, you can easily calculate the quantity of another. It's like connecting the dots. With practice, stoichiometric calculations can become second nature, like solving a Sudoku puzzle. So we've journeyed through the fascinating world of chemical formulas, reactions, and stoichiometry. We've unraveled the mystery of empirical and molecular formulas, revealing how they represent the simplest and actual ratios of atoms in a compound. We've witnessed the magic of chemical reactions where substances transform into new ones, guided by the laws of nature. We've explored the recipe of chemistry, stoichiometry, and its principle of conservation of mass, ensuring the same number of atoms before and after a reaction. Lastly, we've cracked the code of stoichiometric calculations, a vital tool to predict quantities in reactions. But the beauty of chemistry goes beyond these concepts. It's a symphony of atoms and molecules, dancing and interacting in perfect harmony. Remember, chemistry is not just about memorizing formulas. It's about understanding the symphony of atoms and molecules. Thank you for watching. Please like, share, and don't forget to comment below. Subscribe to our channel, Facts Academy 0122, for more exciting facts about the world around us.